Variable.
Yeah, I looked at all the answers after I just did the
No. Okay, wait. I haven't even said anything yet. You cut me off like mid-sentence. For every, let's suppose I just go through counting all the decagons, right? So we go like decagon, decagon, triangle. If I do that, if I add up the number of decagons plus the number of triangles, then I just get the number of faces. That's a fact. Okay, but now, suppose I'm counting vertices. Well, one way to count vertices is to go, no, you're right, I guess it doesn't matter, right? Yeah, it's just 10 times every decagon plus 3 times every triangle. If I do that, then I am triple counting every vertex. So it's going to be 3 times the number of vertices, so it's 180, yep. And now if I go through 10 times the number of decagons plus 3 times the number of triangles, double counts every edge. Yep, it just does. And so that same relationship, that we saw yesterday is that the number of edges is just going to be 3 halves times the number of vertices. So the number of edges is 90. Yep, boom. And therefore the number of faces has to be 32. Yeah.
Isn't the number of edges always going to be v over 2 times however many faces meet at a vertex?
Yes. Yep.
I stopped right.
Okay, because it's just obvious. Yeah. Good. All right. And then how many decagons and squares are there? Triangles. Well, yeah. I guess I could just be like, all right, how many triangles? If I count every vertex on every triangle, so 3 times the number of triangles, then I claim I've counted every vertex. Let me say that differently. Every vertex is on exactly 1 triangle. So if for every triangle has 3 vertices, I've exactly counted the number of vertices, which is 60. So therefore, there must be 20 triangles. And now with the dodecagons, you have to be a little bit more careful, right? Or you can just, obviously you can just do that, but just go through the kind of counting argument in general. Now, if you count every vertex on every dodecagon, you've double counted the vertices, right? Because every vertex is on 2 dodecagons. So 10 times 10d is 2 times the number of vertices. And there's 120 vertices, so there must be 12 decagons, which is obviously true. Cool?
There are also 12 pentagons in a dodecahedron, so there have to be 12 dodecagons.
That's using like intelligence. Yep. Good. All right, let's do one more before the bell rings. Woo! Next, rhombicosidodecahedron.
Are you gonna ask about that one?
Yeah.
Is that like the rhombicosidodecahedron, but with an icosahedrodecahedron?
That's one of the hardest ones.
It's
this one. It is the rectification of the icosahedrodecahedron. This is the icosahedrodecahedron,
which is itself a
rectification of the dodecagon and or icosahedron. Anyway, this is the icosahedrodecahedron. Amazing. Rectification of the dodecahedron, rectification of the icosahedron. If you rectify it, man, then all these pentagons become pentagons. Triangles become triangles. But every vertex becomes like a square, or rectangle-ish, but like you make it a square. Alright, so that's what this is. But really what's important, and what I suppose I would just give you, is that locally every rhombicosidodecahedron is a 5, 4, 3, 4. That's like what's relevant, yeah? Okay, given that information only, find the number of vertices, edges, and faces, go.
Okay, so what's the angle of these?
12 again. They're all
12 again.
They're all 12.
All 12?
On
That's crazy.
they're all 12.
That's crazy.
Did you just pick?
I just picked whichever one looked kind of cool. So the one interior angle of a pentagon is like 108, yeah?
Yeah.
Plus 90 plus 60 plus 90.
Yeah.
Still 348.
12.
348, yeah. 12 degrees. So it's again 12 degrees. So how many vertices? It's So there again have to be 60 vertices, okay? One down, more to go. Now we have to be a little bit careful, right? Because if you take the...
Just use that. Be over 2 times.
Yes, I'm just talking about, you get it immediately, I'm just talking out for the people at home. So now, if I add, yeah, good. If I now, looking at a vertex by vertex basis, if I now count, I have to be a little more careful the way I do this, right? Because now I want to say that if I take the number of pentagons plus twice the number of squares, I think this is how I want to put it. Yeah, right? If I count every, no, take it back. Just S. Yes, P, it is the same. P plus S plus, the hell am I doing?
T.
Plus T. Then what have I done for every vertex? I have quadruple counted every vertex. That's like the key point, right?
Multiply yes and T by like 5 or
Yeah.
Wait, I messed something up. Sorry, yeah.
It's 2,
Yeah.
it's 2S.
So sorry, 5.
Or, oh, yeah.
No wait, I have to. I'm only 80% sure we're doing this,
That's
right? But I think we are.
Yeah.
So wait, hold on. Let's just talk it out. If you go to every pentagon, count 5. Count 5 vertices in every pentagon. Go to every square, count 4 vertices. Yeah. Go to every triangle, count 3 vertices. What have I done?
Quadruple counted.
Yeah. So even the fact that there's 2 squares means it doesn't matter. Yeah. Sure.
Well,
Yeah.
have you
No, you have
No, you
quadruple
have
counted because we just counted every square.
Because 2 squares still share,
Mhm.
2 squares still share.
Yeah.
Yeah, every vertex is on 2 squares. So by counting every square 4 times, we have counted each vertex precisely 4 times. So that's key. And then of course, if you do 5 pentagons plus 4 squares plus 3 triangles, the 5 edges per pentagon, 4 edges per square, 3 edges per triangle, so you've counted every edge twice. So now the ratio is that the number of edges for this shape, because there are 4 faces meeting at each vertex, is just twice the number of vertices. So that's like 120. Cool? Say cool. Alright, and then the number of faces then must be 62, yeah? Yeah. Good. And then how many of each? Well, we can just go through the pentagons again. 5, if you count the vertices on every pentagon, you've counted every vertex exactly once. So then there must be 12 pentagons, etc., etc. 20 triangles by the exact same logic. 3t has to be the number of vertices, so there are 20 triangles. And then there's just like leftover whatever. Must be 30 squares. All right, good. People at home, goodbye. AP week is basically over, right? No APs tomorrow?
I have an AP tomorrow.
Yeah.
Great.
Only there's irrelevant ones tomorrow, right?
Yeah, I'm taking the relevant ones.